Section 3.3 and 3.5, you'll notice 3.4 was skipped. Again, I mentioned in the first video that I'm going to jump around a little bit. You don't have to worry about that. I'm the only one who has to worry about that. So we're going to go through function notation. We're going to talk about a different way of writing a function rather than just y equals something. We're going to talk about a different way of writing it and how we can use that new notation to do more complicated problems, which I'm sure you're excited about. There we go. So this is the way we've been looking at equations, at functions. Y equals 8.5x. This is a function because if you plug any number in for x, multiply it times 8.5, you're only going to get one number out. You won't get two different numbers out if you multiply times 8.5. So this is a function. A different way of writing that is like this. This is called function notation, and the way it's read is the function f of x. So we'd say f of x is how we would say that. So the function at x is 8.5x. And that, basically it's replacing the y with this new symbol, function of x. And at first it's going to seem kind of trivial, but as we apply more things to it, it'll be more useful. So the way we'll start small though. The way that we use this notation, we write problems with this notation, or the question you might be asked is, what's f of 0? Basically what they're saying is, what is the result of this function when x is 0? So, or f of 10 or f of 20, the function when x is 0, what is the result of this function when x is 10? What is the result of this function when x is 20? So when x is 0, it'd be 8.5 times 0. 0. So the solution, if it says, what is f of 20? Or excuse me, what is f of 0? Your answer would be 0. That's it. That's really what it's telling you is, x is 10, substitute 10 in for x. So what is the function at 10? The function when x is 10, 8.5 times 10, 85. So the solution, the answer is 85. What is f of 20? F of 20 is 8.5 times 20, which works out to be 170. So that's how that function notation looks. That's how it works. That's what functions, to use that word again, is the function, whatever our function is, at a specific point when x is 20, we plug 20 in for x, and we get a result. Okay, so now let's look at another situation. So we've got a function, f of x equals x squared minus 1. So we've got a slightly more complicated function, not just 8.5 times x. And we're asked to find two different things. We're asked to find f of 2, and we're asked to find f of a plus 3. So it doesn't have to just be a number. It could be a new expression in there. So let's start with f of 2, because that's a little easier. So we plug 2 in for x, f of 2, x becomes 2, so we got 2 squared is 4, minus 1 is 3. So we would say the function at 2, f of 2, equals 3. But we're going to look at the next one, f of a plus 3. Well, a plus 3 is this expression. Whatever is in the parentheses here, we're replacing x with that expression. If that is 2, we replace x with 2. We substitute. If the expression is a plus 3, we substitute a plus 3 in for x. A plus 3 squared, we spent a fair amount of time on this in chapter 2. You can expand this out. You can FOIL, you can expand it out. It would be a plus 3 times a plus 3, which becomes a squared plus 6a plus 9 if you do the work there. And I'm going to trust that we've done enough of those that you don't need to see me do it. So expand that out. And if you then subtract 1, because again, a plus 3 squared would be a squared plus 6a plus 9, minus 1 would be this. So f of 2 is 3, f of a plus 3 is a squared plus 6a plus 8. And that's how you do it, or that's how you answer questions that ask you to evaluate given an expression here, a plus 3, instead of just a number 2. All right, now let's look at combining functions together. And so we're looking at these compound expressions, is what this would be called. We've got two different functions. We've got f of x equals 3x plus 4. So we got this function here. We have another function. They can't use f again because we've already have an f of x. So now they go to g. Usually they start at f because f is function, and they go to g, then they go to h. And so depending on how many functions we have, they use different letters, but it's the same notation, just a different letter. So f of x is 3x plus 4, g of x is x squared minus 2x. These two problems here, we're gonna work from the inside out. Kind of like if you were solving a problem, you work from the innermost parentheses, and then you kind of work your way out from there. So we're gonna figure out, this says the function f at g of 3. So this is f of g of 3. So we want to know what's the value of the function at whatever g of 3 is. So first we have to start with g of 3. So we're going to start with this inside expression. G of 3, we have this function here, g of x equals x squared minus 2x. So g of 3, 3 squared is 9, minus 2 times 3 is 6. So g of 3 is 3. I'll go back here, sorry. So g of 3 works out to be 3. Once I know what g of 3 is, g of 3 is 3, I can substitute that in for f of x. So this says, what is the function at g of 3? Well, I know g of 3 is 3, so I'm going to take the function f at 3. And again, this 3 here was because this result, 3 squared minus 2 times 3 was 3. So I took that result and put it in for f. And so, okay, now what's the function f of 3? 3 times 3 is 9, plus 4 is 13. So we would say the function at g of 3, f of g of 3 is 13. Let me do another example of that. Let's look at this one. So we've got g of f of 2. So again, I'm going to work from the inside out. If I want to know what g of f of 2 is, I first need to know what f of 2 is. So I'm going to start with f of 2. So I can plug 2 in for the function f of x. F of 2 is going to be 3 times 2 is 6, plus 4 is 10. So f of 2 is 10. This circle, this red circle here is 10. So I want to do g of 10. And again, this 10 here is because f of 2, the function f of 2, worked out to be 10. So I take that 10, I plug that in for g of x. I'd say g of 10 is 10 squared minus 2 times 10. So I'm going to get 100 minus 20. G of f of 2 equals 80. So you work from the inside out. You do the innermost function first. Whatever that result is, you plug that into the second, the outermost function, and figure out what that equals. So you're doing two different functions. You're substituting twice, basically. Now this f parentheses g parentheses 3 is correct. There is a different way of writing it that you might see. Same thing with g parentheses f parentheses 2. It might look like this. So the way this is written, the way this is read, is f of g of x. And so this notation is the same thing. Sometimes this is called fog of x, because it looks like FOG. But fog of x is f of g of 3. Similarly, g of f of 3 can be written g of f of x. We would say goff. I know it sounds weird, but it's true. So we have fog and goff. Fog is f of g of 3, and goff is g of f of 3. Basically, if it's in this notation, you want to start with the f of x, or you want to start with the function closest to x first, and then go to the outermost function. Again, over here, we would do the function closest to x, g of x first, and then we would take the f function, the outermost function of that. Let me leave this up for only a second. You can pause it and write it down. What these say is that not only can we compound functions together, one inside of another, we can add functions together, we can subtract functions, we can multiply functions, and we can divide functions. And I'm going to show some examples of that here in a minute. So if you see this notation, this means add the two functions together. If you see this notation, it means subtract the two functions. This notation looks similar to fog, but there's no O in between. There's no little circle. And so this is f times g. That's kind of confusing, I agree, but that's the notation. And this means division. F over g of x is the function f divided by the function g. Again, go back if you need to write those down. All right, so I've got two functions